Before we get into covering radicals, we do need to have a review over perfect squares and perfect cubes. Alright, so for a perfect square, if you were to take a number, and I have numbers here from 1 to 10 listed, and I'll just take a number and multiply it to itself, 1 times 1, or I could say 2 times 2. So what you're doing is repeat multiplication. I'm going to take the number and multiply it to itself. That process is called squaring. So 1 times 1 could be written as 1 squared. The 2 indicates that it's 1 multiplied to itself twice. So again, 2 squared means 2 times 2. 3 squared means 3 times 3. And so on. And doing that multiplication, you find that 1 wouldn't change. You would have 4, 9, 16. So through this process, we're just taking the first 10 numbers. The list could go on longer, but we're going to keep it to the numbers from 1 to 10. And if you said 5 squared, you'd end up with 25. These numbers here are referred to as perfect squares. So the next perfect square, 6 squared is 36. 7 squared is 49. Then you have 64, 81, and 100. You should be familiar with the first 10 perfect squares. I'd have them committed to memory. And if we were talking about perfect cubes, well, perfect cubes refer to numbers that are multiplied 3 times. So you say 1 times 1 times 1, which will be written as 1 cubed, or 1. 2 times 2 times 2, or 2 cubed, which is 8. 3 cubed, 27. 4 cubed, 64. 5 cubed, 125. And the list itself will continue. 216 and on. You wouldn't be expected to have these memorized, not the full list, but it certainly does help to know the first 6. Alright, once you have an understanding of what perfect squares and perfect cubes are, you also need to know how to reverse the process. And what I mean by that, if you had a number 144, I'll just pick the number 144, and I asked you what number was squared in order to give you 144. So go back here, and I'm asking you what number is squared to give you 144. Well, if you don't know the number, instead of saying question mark, let's just say x. Then you would have to perform an operation called square root. And you get 12. So you have squaring and you have square root. Square root does the opposite of squaring. Some things you need to know. This is actually called a radical. The sign that's there is called a radical sign. So the whole thing is a radical. The sign itself is a radical sign. So when we're dealing with radicals, we're dealing with roots. Now, not only would they be square roots, but you also deal with a cube root. Alright, let's say for instance you had the number 512. And you were asked what number multiplies 3 times. So some number multiplied 3 times. So I don't know what the number is, so question mark. But if I multiply it to itself 3 times, I'll get 512. So some number multiplied to itself 3 times is going to give me 512. But to figure this process out, you use something called cube root. With this 3 here, it doesn't get written in front of the radical sign. It gets written on the lip here. So let me tell you something about numbers written here. That's actually called the index. And it tells you what type of root you're taking. So it means I want to find a number that multiplies 3 times to itself. So if you type this into your calculator should have the cube root button. If it doesn't, then when I get back, I can go through that with you. You would get the number 8. So what that means is that if you said 8 cubed, you would come back to 512. Alright, so let's do a quick recap. So you can square numbers and get your perfect squares. Cube them, you get your perfect cubes. If you want to reverse that process, then you get into using roots. Roots altogether are called radicals, and that's what this chapter is about, dealing with root signs or radicals. Okay, so what we do here now, we're going to stop and go through just a couple questions here. Then you're going to do some for homework. Okay? Alright, so I'm going to just pick a couple questions, and I'm going to start with number 2 first. So if you're asked to do square root of 24, well, square root of 24 is not a perfect square. If you look up to your list here, you don't see 24 written there. So what you would do is you need to know a factor, a number, a perfect square that divides into 24. So out of that list, we have up here perfect squares. Which one of these can multiply to give you a 24? Well, one goes into anything, but we just leave that out. You could say 4, 4 times 6. Does 9 go in? Nope. 16 go in? Nope. Well, and then you got bigger than 24, so you would stop. So 4. And try to remember, this is a review of stuff from last year, so this should seem totally new to you. So 4 times 6 is 24. Then you could write that as square root of 4 times square root of 6. So this radical sign that's here, that radical sign, can get split over both factors. Now remember, when you're doing multiplication, each of the numbers, the 4 and 6, they're called factors. So you could split the radical sign over both factors. Alright, now work out the math. The square root of 4. What number multiplies twice to give you 4? 2 does. Is there a number that multiplies twice to give you 6? Nope. So you would leave it here. And this is called a mixed radical. So the question says, write each as a mixed radical. Well, this is what a mixed radical is. Alright, let's pick C. So square root of 60. Out of your list of perfect square numbers. So this is why it helps you to know them, have them memorized. And you could even write them down on a page if you want. Which of these numbers here can multiply to give you 60? Well, if I'm looking down through the list, 4 does again. Okay, perfect. So 4 times 15 is 60. say square root of 4 times square root of 15. Square root of 4 is 2. And I cannot do the square root of 15. So written as a mixed radical. Your other option in question 1 is to write them as what's called entire radicals. So in this question 2, we started with entire radicals. So we start with what's called an entire radical, and we change it to a mixed. Well, in question 1, we want to change it back to an entire radical. So here, we have 3 square root of 5. So I want you to take that 3 and you're going to force it back underneath the radical sign. Now, it's not so simple as just to put the 3 back underneath. You have to square it. So when you put the number back underneath, you're going to square it. It becomes 9 times 5, 45. And let's just look down here at what we've done before. If I want to reverse question C, what we just done, this was a root 4, but it became a 2 because you took the square root of it. So if you put the 2 back underneath, how do you get that to become a 4 again? You got to square it. And that's what you need to do here. Numbers on the outside go back underneath the radical sign, and they get squared. So let's pick C. So you write your radical sign. You take the numbers on the outside, in this case the 8, you write it underneath, and square it, and say times 9. Then you would have 64 times 9, and 64 times 9 is 576. Alright, actually I'm going to leave it there. I think that's enough for now. And when we get back in class, I'll go over this with you again, and then I'll get you to do some more questions. So we'll call it enough there.